Hi, Dr. Johnson. It's my last video reflection for you. I wish Brittany could make a guest appearance, but she's also at work. And you have a really nice scenery of my classroom and my fire extinguisher. Okay, this second reflection came at a really good time because I just finished reading all of the articles for that jigsaw about culturally responsive teaching in STEM, and I have a lot of thoughts about it. But as I was reading, I sort of saw a delineation between two major needs in furthering culturally responsive teaching. The first one being removing barriers, and then the second one being implementing culturally responsive teaching, or implementing equitable curriculum. But the removal of barriers still to me feels like really low-hanging fruit of culturally responsive teaching. The articles that I was reading was still talking about shaming students for their first language, or just ridicule of them for their natural culture. And that seems I guess maybe I'm just surprised that that's still something that we're having to talk to teachers about. But it is a barrier that students face when their culture doesn't match the majority culture. So removing barriers as far as ridicule and shame, and honoring students' natural culture, the culture that they bring into the classroom and the background that they bring to education, is obviously one of the first things that has to happen for teaching to become culturally responsive. But it to me feels similar to when your colleague, I can't remember her name, in the lecture we visited, was talking about how we still need storybooks for our little kids that have characters that look like them. I'm yes, why are we still talking about this? This is the low-hanging fruit of culturally responsive teaching. This isn't all that needs to be done. So removing the easy barriers that prevent kids from accessing an equitable education, but then also removing the systemic barriers. I think it was either the Peralta article or the Wassel article. I can't remember which, even though I have my notes in front of me. I think it was the Peralta. Talked about it. They interviewed a bunch of Latinx adults about their experience in schools, and a lot of them said they were either actively discouraged or just not encouraged to take more rigorous STEM courses. And so tracking as a system in schools, from counselors or from teachers, needs to be addressed as a removal of barriers to if culturally responsive teaching is ever going to work, and just if equitable education is ever going to happen. We have to start recognizing STEM talent in our kids. And I think something that will help that is by implementing better curriculum. So before I get into that, though, the first thing I saw in reading these articles is we have to start removing barriers that prioritize one type of culture or one type of student. But then in addition to that, we also need to start reimagining what culturally responsive curriculum looks like and practices in the classroom look like. And so as I started thinking about STEM, it's something that's tricky and it's kind of frustrating to me is I've never really been shown a model for this is culturally responsive teaching in STEM. I feel I'm constructing that vision in my mind, but I feel like I haven't really seen it done to fidelity of what it could be, which is, I guess, exciting because I have this really idealistic idea of what it could look like. But no one's that I have ever seen is doing that. But I have started to think through what would in an ideal world that was equitable and culturally responsive, what would STEM education look like? And the Lacona article kind of started to touch on that when it talked about the funds of knowledge that our kids bring and how they their cultures and their families are experiencing STEM concepts. Everyone's experiencing STEM concepts. One of the best, the Lacona article quoted Kovalik and Olson and said that we are all born scientists trying to make sense of our world. So no matter what culture you're in, you're encountering STEM concepts, whether probably more likely if you are in a low-income, poverty-ridden community like the one that Lacona was observing. They were doing so many things that were involving STEM concepts. They were like building additions onto structures. They were recycling water in very cool ways. They were like constructing air ventilation systems and water heating systems. They were positioning their buildings in relationship to the sun to maximize heating and cooling. They were moving outdoor sinks from like one tree to another to water their plants, because that in turn allowed them to have trees that grew taller and shaded the house. Like, they really are encountering a lot of STEM concepts, and we have to recognize that our kids bring that into the classroom, and we could teach them about the water cycle from a textbook, but we could also just teach it to them in a way that honors what they know and what their family knows, and the wealth of knowledge that exists intergenerationally in their families and in their communities. But something that article touched on at the very end is like, if we're ever going to know that, if we're ever going to be able to access that, we have to understand the lives of our students. And to me, that would require so much more time spent in the community and home visits with students. And that's just not built into the culture of what it means to be a teacher in America right now. And I think part of that is that it just favors, like, there's an assumption that I understand what their exposure is like to STEM concepts when I don't. I think that's like a systemic assumption that we make, like, but there's no way to connect our students' funds of knowledge with the concepts we're trying to teach them in STEM if we don't know what their funds of knowledge are. Like, that was a sticking point for me on that article, is like, this is amazing. Learning what these communities are doing and the way that they are encountering STEM concepts is amazing. And that knowledge as a teacher would completely change the way that I teach different STEM concepts, but I don't know those things until I know them. And there's got to be some more creative ways for us to learn what funds of knowledge our kids bring and our communities have. That article also talked about just the challenge of teaching through inquiry, and I've spent a lot of time thinking about like how I'm not actually giving my kids a good science education when I'm just lecturing at them about science concepts. And what's tricky about that is that that's how I was taught science, even through college. Like, we weren't really doing science. We weren't really given an education that is inquiry-based or teaches us how to critically solve problems. We were just lectured at about science concepts and experiments that other people have done. And I think, as I think through, like, what would an ideal STEM classroom look like, it's so different from what it looks like now that it's hard for me to think through, like, what it would take to get us there or to get us closer. But something that I found a couple years ago is a structure of, like, labs called argument-driven inquiry. And I'm very obsessed with it because it models what science looks like when it's done in academia, as far as, like, the process. So kids have to identify a question. So kids are writing their own questions. They're designing their own procedure for how to answer that question. They're carrying that procedure out. They're recording data, and then they're presenting it. They're using that data to support an argument, like a conclusion. And then they're presenting that data to each other, giving each other feedback on the validity of how their data supports their conclusion, or the strength of that argument. And then they're writing it in a paper. So it's like it's student-centered from the very beginning to the very end. Teaching in that way requires a lot of flexibility and a lot of resources. So I've had to adapt what an argument-driven inquiry lab looks like in my own classroom in a couple ways. I did it in the biology classrooms. I haven't done one in a physics classroom yet because my depth of understanding the content, I think, honestly, is not there. And it's my first year teaching. But in the biology classes, I started developing ADI labs. And so, for example, I wrote one about evolution because it was one of the harder concepts for our kids to grasp and pretty boring to teach them if you just tell them. So instead, I gave them a question. We looked at orangutans, chimpanzees, and gorillas, I think, and we said which of these three are most closely related to humans. So I gave them the question, both as far as, like, I need you to hit some, like, I needed to incorporate these things that were TEKS-based, but also scaffolding the skills. I don't think that I could have just, like, told my kids to come up with a question and let them do question procedure data. Like, we needed to scaffold some of those skills because students have never been in science classes that are, like, fully inquiry or are implementing inquiry with fidelity. And so having to scaffold some of those, like, critical thinking and initiative skills was something that I thought about too when I was designing the lab. But it was cool because I could present them evidence. I could give them evidence that was aligned to TEKS. So we looked at molecular homology, biogeography, and anatomical homology, and I think one more. And we just gave them the evidence and let them decide. And what was cool is that the evidence doesn't all point to the same thing, which is just real in science. We don't always have evidence that totally supports one thing or the other. And so different students had different conclusions, and then we got to discuss the validity of the data that support, like which data was strongest in support of which arguments. But what I loved about teaching like that is, one, it really did allow kids to be expressive and to think in their own ways, and then to communicate the way that they were thinking and to be validated in that. It also allowed them to apply, this one, not so much, but other labs that are ADI labs would allow them to apply their own knowledge to the lab. So now we're actually constructing like an understanding of science together based on what we know as a class, which is very different than me just telling them about experiments that people have done in the past. And I don't believe that the way that science education has been done in the past teaches anybody how to be problem solvers in their communities. And so I see just this huge potential for where STEM education could go as it's like founded in communities, founded in students' funds of knowledge and their families' funds of knowledge, and rooted in inquiry-based learning. It just would take such an overhaul of what a classroom, a science classroom, should look like, and that would take the support of admin too. So anyway, I was thinking about just like what an ideal STEM classroom could look like, and my creative wheels started spinning, and then I got discouraged thinking about what it looks like now and how we would take little steps. But in order to do that as a teacher, I would first of all have to be teaching in a content that I had a much deeper content knowledge of. So I'd have to go back to biology. And then I thought about the lab school in West Dallas and how cool of an opportunity it is to build a STEM school from the ground up and to like really imagine like not what normal classrooms look like, what would an ideal STEM classroom look like? What are some of the things that would be a part of it? And I think it's just a cool opportunity to be able to reimagine that from the beginning. But anyway, those are some things I thought about when I was reading. I'm way over time. I'm really sorry, but I have a lot of thoughts about STEM education and it being culturally responsive and both inquiry driven. And not only that, honoring our students' culture, but actually building scientists. Like that actually teaches kids how to think critically, teaches them how to solve problems in their community. It also teaches them to look at like data and evidence for things. Something interesting that I've come across this year is a lot of 17-year-olds, a lot of my students believe in a lot of conspiracy theories, and when you ask them like what their evidence is for that, their evidence like doesn't hold the basis for truth. So I've also thought about like science education also has to have some conversations around like where do we get knowledge from? How do we know things? Seems like it should be a place that we start with science, because kids will push back on me and say like, no, I watched a YouTube video that the earth is flat, or like my pastor said you're wrong and evolution isn't real. And like those kind of like conversation enders aren't building students who are thinking critically about evidence. And so there's just like a million things that I would do differently as a STEM teacher. And one of them would be starting with like, what is knowledge and what is truth? And that is probably a lot bigger than what we're normally tackling in STEM classes. But if we're going to build kids who are critical thinkers, I think that's something where someplace we need to start. Like, what is evidence? And why does it matter when we make claims? And how do we know what we know? Anyway, basically, I just want to teach philosophy and all STEM subjects in one class. Like, let's do math and science together and philosophy. But education isn't built like that. So I feel very idealistic and stuck. But I think there's room to move forward. Now I'm actually done. Okay, those are my thoughts. See you in class this week.